In this lecture, I'd like to walk you through the contents of this course in detail. What you're looking at now is a full course map. Each of the red bubbles consists of one section in the course. So we'll start with having a look at the Raspberry Pi, then the operating system, installing it and showing you how to do a backup and recovery. Then we'll talk about GPIOs and use Python to control LEDs and read button statuses. We'll look at the web application stack, then about styling and storing data in a database. Then we'll start working on the core application features, deal with dates, represent data visually inside charts, and then use widgets to interact with our application quickly. We'll look at time zone conversions, then do more charting using Plotly, and finally I'll show you how to publish your web application onto the internet so that you can use it from anywhere you might be. So let's begin with the first section. We are going to have a close look at the Raspberry Pi. First, we'll look at the specifications and the features of the Raspberry Pi. I'm also going to compare various Raspberry Pis together, that's various Raspberry Pi models together, and see what the differences and similarities are. I'm also going to compare the Raspberry Pi against the Arduino, because I expect that a lot of people doing this course are already familiar with the Arduino, and a question that I often get is, what are the differences? Which one should I be using, the Arduino or the Raspberry Pi, or both, and why? So we'll look at that in this lecture. We'll continue with the operating system. Unlike the Arduino, and here's one big difference, the Raspberry Pi needs an operating system to be useful. So this is what this section is for. We'll start with having a look at the various options that you can use, especially when it comes to the Raspberry Pi 3. There's a lot of different operating systems that you can use, so I'll have a look at some of the most common options. Then I'll explain the differences between the headless and a GUI, a graphical user interface type operating system, and I'll explain why in this course we have chosen to use the headless version of the Raspbian operating system. Of course, then I'll show you how to install the operating system on your Raspberry Pi's SD card and to connect to it from your host computer for the first time. Before we do any more work in this course, at this point I'm going to show you how to backup and recover the contents of your SD card. So backing up your SD card is a fairly straightforward process, although it does take a little bit of time, but it's like insurance. You will be investing a lot of time setting up your Raspberry Pi, the operating system, the various services and servers and software that make up your application, and of course you'll be writing a lot of code, and it'd be a shame to lose all that because perhaps an SD card becomes corrupted or there's some damage in the file system, and a lot of other things that often are out of your control. So I'm going to show you how to back up your SD card on the Mac OS and on Windows 10, just in case something bad happens. Of course, backing up your Raspberry Pi is only half of the whole process. You need to know how to restore your operating system, how to restore your SD card from a backup, and I'll be showing you how to do that also on Windows and on Mac OS. Time to start playing with the Raspberry Pi and its GPIOs now. So in this Python and GPIOs section, first we'll talk about what GPIOs are and the different types of numbering systems that are used, which is another difference between the Raspberry Pi and the Arduino. On the Raspberry Pi, there's a couple of different numbering systems and addressing systems for all the pins on the GPIO header. And in one of the lectures in this section, I'll explain how that works. And then we move into Python. Although the Raspberry Pi, because of its Linux operating system, has provision for pretty much any programming language that exists, the vast majority of documentation for the Raspberry Pi uses Python, and Python is the most common language used to work with the Raspberry Pi. As you'll see in this demonstration, in this lecture, using Python on the command line without even having to write a program is very easy and straightforward. So we're going to spend a bit of time on the command line, turning LEDs on and off and playing with buttons, and eventually working with libraries and the DHT22 sensor as an example of some more sophisticated sensor operation that you can perform again with Python. In the next section, called the Web Application Stack, I'm going to introduce you to the Web Application Stack. So the Web Application Stack is the architecture on which we will be building our application. So I'll start first by explaining what the application stack is, then what the Python virtual environment is, which is another one of those mechanisms that the Raspberry Pi provides thanks to access to high-level development tools, unlike the Arduino, which makes it easy and safe for us to build multiple applications on the same piece of hardware, on the same computer. And later on in this section, I'll show you how to install, set up, and configure the basic components of our web application stack. And that's the Nginx web server, the Flask micro framework for building Python web applications, the UWSGI application server, and systemd for automatically starting our web application when the Raspberry Pi starts. Then we'll move on into the style and persisting section. In the style and persisting section, I'll show you how to use the skeleton boilerplate CSS system to make our application look good. Then I'll show you how to implement persistence using the SQLite 3 database engine. And finally, I'll show you how to deal with bugs, how to do debugging using the information that you can get from various log files or information that you see displayed on your browser. Now we are starting to actually work in building our application, and in the core application development section, we'll begin with the first page. We'll get data from our sensor and display it in the web browser so that we can easily check on the temperature and humidity of our lab. I'm also going to show you how to record this information in the database so that we can retrieve historical records. And of course, we don't want to have to manually grab information from our sensor and store them in the database. So I'm going to show you how to automate sensor measurements and creation of records in the database. As we are storing more and more environmental data records in the database, eventually we will develop the need to filter out those records according to dates and times. So in this section here, we'll do just that. I'll show you how to retrieve records from the database based on a specific date-time range. Then I'll show you how to use query strings to pass that date-time range information from your web browser to the server so that the server can react. And because we don't want to have to manually set the date-time ranges in the URL of our web browser, I'm going to show you how to use jQuery to create preset buttons that we can use so we can easily navigate back in time. At this point, our application is becoming more sophisticated. We have already collected a lot of data from our sensors, and what I'd like to show you next is how to improve our application by first implementing Google Charts. So we'll use the Google Charts API to convert our raw data into nice looking line charts, and how to use the date time widget so we can easily define the date time range for the data that we are displaying in our browser. There's also provision for time zones. So by default, our application is time stamping our records using UTC, which is the convention when it comes to timekeeping on server machines. But of course, it will be useful to be able to convert those UTC times into our own local time zone to display that there is timestamps for records on the time zone of your computer. So I'm going to show you how to use jQuery plugins on the client side and Python modules on the server side in order for these two together to deal with time zones in our application. In this section on Plotly, I'm going to show you how to do data visualization and analysis using the Plotly Python library. So first, I'll explain what Plotly is and give you some examples of how you can use it on the command line. And then we'll start implementing a little bit more functionality in our application so that we can send sensor data to Plotly where it will be visualized. And while we're at it, I'm going to show you some more debugging tips and tricks that will help you a lot in dealing with inevitable bugs as you're working with applications of this kind. Now, last but definitely not least, at this point, we will have completed development of our application. And the last thing I'd like to show you is how to publish your application onto the internet, how to make it accessible from any connected device on the internet. So first, I'll show you how to assign a fixed and constant IP address for your Raspberry Pi, and then how to expose your web application to the internet. So I hope that you find all this interesting and you are eager to get started. Let's move on.